Всем привет. Спасибо, что отвлеклись от ваших важных дел и пришли послушать наш доклад.
Well, thank you very much for having taken yourself away here to listen to our presentation. In it, we'd like to tell you about how we had to break some ATMs, to protect the banks using them. Those who've been to our presentations earlier than that, in previous PHDays, already perhaps would be interested to know that we now work for Kaspersky Lab. We take part in different events, so if it should happen at the Black Days and Heart and Berries, whichever, you're welcome, and we're going to report there. So our main work is to run the analysis of security and safety of different secure systems and to penetrate them in different ways. To start with, I'd like to tell you what an ATM is, because as experience shows, not everyone has a clear picture what it is. Even people working with ATMs don't always know how they work inside. An ATM is basically a Lego block for, big daddies. So there are all sorts of hardware modules produced by all sorts of companies. They are put together in a box, and then you get an ATM. The top part of an ATM, the so-called service zone or a cabinet, hosts a system block, which is or looks or almost the same as for desktops at home. Apart from that, there's a card reader, a pin pad, the CCTV camera, and other devices. All devices are connected to the system block using COM and USB ports. And there are also older models where you have another bus. The vendor believes that the service zone is not about money. The service zone is covered by some plastic cover with just one lock. And each vendor for the entire line of ATMs has the same lock. Some banks change them when they start understanding that locks all over the world in all ATMs of the specific producer are the same. Some of them change the locks by unique ones, but most don't even think about it. The lower part of the ATM is about money, so it's a safe box. It's a sandwich of steel and concrete with two types of lot. The safe contains all devices having to do with the money, with the cash dispenser to dispense the money. They normally have 4 cash cassettes and 2 rejects cassettes. Each cash cassette contains from 2 to 3,000 bills. So therefore, each ATM contains about 15 million rubles or maybe $10 million or euros. So you can understand that the attacker can reap a benefit of that value from just one attack. So it's clear that not always and not every ATM has this much money, but this gives you an idea of the average check, so to speak, for each attack. Also, the safe contains different cash-in modules. Now about software. The system unit runs an operating system, typically Windows. They also host the main software controlling the ATM, the UI to interact with the user, or the engineer and collector. And on the other hand, a module to communicate with the processing. And also the middleware modules to control the hardware modules of the ATM, such as card readers, dispensers, and the rest. Also, some banks use different antiviruses or integrity control systems. Sometimes they install video surveillance over the same unit. Sometimes you see strange things such as an obsolete archiver or backup system, the old version of Flash player, other curious thing. And I'm calling them curious because their vulnerabilities are very well known. Regarding the hardware, it's all strange and not easy to understand because these are all real-time controllers that people who love ID Pro don't like at all. So this is the schematic of a typical ATM, where we see that the Windows-based application is the main software that controls the ATM, that accepts commands from the processor and translates them to the hardware via the XFS manager. Different vendors call them differently depending on their whim, but the entire software is PixFS compliant. This is a set of specifications to simplify the operation of an ATM, regardless of the manufacturer. The standard was developed in 1991 and started to be developed by Microsoft. And this should basically give you an answer why Windows. So using this XFS manager, the main application translates the commands to service providers, to different drivers, and then via the service provider to the hardware dispenser, pin pad, and the rest. The status responses or other responses to commands return the same way, just the opposite direction. And yes, you're going to laugh, but Windows XP is still used in ATMs. Some experts say that XP doesn't exist, that embedded systems are used in ATMs, but there are very few. Some banks were in time to migrate to Windows 7 recently. You can still find ATMs running Windows NT and even OS2, but the vast majority runs Windows XP. As you can see, any vulnerabilities identified there later on will never be fixed. On the other hand, there are banks whose ATMs run software and operating system that is never updated. So once it's been installed, the way it runs and how it runs, Alexei, my colleague Alexei, will tell you. Hi, everyone. We were talking about malware, XFS. Let's now speak about the network. The atypical ATM network looks like this. There are lots of ATMs across the country, maybe across different countries if it's a multinational bank. They are connected through different technologies with the processing center, but this is the minimum that is required for an ATM to run. It would seem that it doesn't make any decisions on its own. Connections to the processing center can be different. Sometimes it's very easy and understood. X25 and Ethernet. Yes, X25 still exists and runs where you don't have anything more than the phone copper wire. So if an ATM calls your phone, please don't be surprised. You can respond. Even more popular are wireless connections, especially when it's about remote connection, remote location. For instance, a small village not too far away from some company where people work. Then it only takes installing an industrial professional modem, and it could use a 2G or 3G network to connect to the processing center on their own. It would seem that's all very good, but GSM and GPRS modems are vulnerable to attacks. Basically, these are all the technologies that have been with us for more than 20 years. Most of you have phones, or sometimes more than one phone. You use the internet, and everything seems to be okay. But there are several different protocols, such as CDMA, GPRS Edge. CDMA is almost done. there are not too many companies in the world who continue using the standard. GPRS is the riding horse of the entire industry and the standard of choice, using which data are sent from RTUs and controllers and whatever else. 3G is expensive, and you basically don't need that speed. Sending from 25 to 35 bytes per transaction, you don't need a pipe like that. As to the encryption of the data, it all looks pretty bad. CDMA has been hacked a long time ago, and there are companies who would charge you $5,000 to $6,000 to get a commercial product that you can install, intercept any requests within the radius of like 300, 400 meters, which is quite enough to intercept control of an ATM, rechanneling a request to yourself. GSM is broken. For instance, our colleagues from Positive Technologies, Arshil Garipov and Pavel Novakov, brought the network up last year, and any user could connect to it. Sometimes they made users to connect to their point, sometimes other, and they were sending some SMS, some text messages. Well, it's clear that if you can send a text message, you can also use the internet connection. So basically, once inside, you'll be able to connect to the processing center. With UMTS and LTE, it's not that simple. There is still information that's not everything is perfect about these technologies. You can familiarize yourselves with the presentations of such people as Carson Owen and Yuri Zaitsev, who spoke at an American conference last year, saying that not everything is good, and how a person with no more than $300 to $400 in their pocket, they could get access to all the sensitive information. It's clear that banks are not happy about this. Who would want that the data of the customers should go outside? To control that, people thought of VPNs. So software, hardware implemented, but the most popular type is the VPN that's not used. So ATMs are connected just like your own equipment at home. Some of them can be found in the internet, and Olga will tell about that later. The software is split into the embedded operating system and third-party software. Because Windows is used everywhere, it's clear that the number of operating systems is quite limited. As to a third party VPNs. There are lots of them from Cisco, Juniper, any other people. But as far as hardware support is concerned, it's quite difficult to separate it. So you can actually distinguish between the tools that operate inside the ATM and those outside. For instance, if you take a look at an ATM, sometimes you see a modem next to them, and that would be exactly what I'm talking about. The advantages of VPNs include the inbuilt firewall. So basically, if you don't know how to pass it, all your requests will be rejected. It runs separately, and it's good and bad at the same time. If the malefactor can attack the ATM software, they are not going to get direct access to the APN client. And it's a good hardware thing that you may take pleasure holding in your hands. But this is also its a drawback. If it does not depend on the operating system, it can be taken, and it can be held in the hands, it can be taken away. And then getting to some cafe with the access to the internet, you can get access to the whole network of ATMs of this specific bank where this thing has been taken away from. Of course, it is not sold by physical access tools. With the software, software implemented VPNs, it looks like everything's good. They're cheap and easy to install. You don't need to buy a piece of hardware before you can install it. You don't have to pay the salaries of the service engineers and technicians, and it'll never break. If ATMs are bound to break, then there's nothing to be done about that. But if a router is broken, it then gets similar to like ATM seems to be up and running but not working. Unfortunately, not VPN clients are useful. Quite often, you can see a sad picture where in the ATM screen, where for some reason the connection goes down, the VPN tunnel goes down, and the screen flashes the a window saying can't continue working. The all data encrypted and containing useful information for malefactors such as PAN, transaction parameters, they will be sent out in clear text. So you just cut the Ethernet cable from the ATM, connect it to your own computer, and you're going to see all the data in clear text. These are some deadly sins that people using ATMs either don't understand or don't want to see. A software implemented VPN is useless without network, without the firewall. The hardware-related one does not sustain the criticism. Using wireless networks seems to be a panacea. Well, security seems to be there, but everybody ignores that it's broken. It has been hacked. People who come and say GSM is broken, they usually get an invitation. Please break my phone, break my social media page. Unfortunately, it all works differently. And if you really want it, it can be done. And the size of that desire is measured by an amount of $400. And then you get a gap between the theoretical knowledge of a bank or organization and the practical applicability. Well, on paper, the ATMs are perfectly protected, but in real life, they're either badly set up because the employees are not competent enough, or can be just bad because the bid, the tender, was won in using some approaches that go beyond above board. The ATM network. So ATMs are installed all over the city, all over the country. And then we get to the situation where the customer, the bank using it, want to control them from a single point. They use such tools as either Active Directory or something else. Some vendors also allow the service of upgrading the ATM software from a central point. But unfortunately, even they don't know everything. It looks like there should be a point-to-point connection, and what they get is like this, a fully meshed situation. We break one, we move to another one. The management server seems to be required, but why would you want it if it's clear without it? So it turns out that we can attack not the ATM itself, and we may not be focused on collecting money from it, cash from it, but we can follow the principle one for all and all for one. But this is just a theory. It doesn't look very exciting. Let's consider how to break it. Take a map. Take the ATM. Scan it for the handbook vulnerability going back into the 80s. It would seem that people MS00067. It would seem that everybody has already updated and fixed it. But the problem is that all the ATMs are rebooted from the boot disk, and people are not prone to upgrade it because otherwise it may break. So an interesting question. What makes the left-hand screenshot different from the one on the right? Ideas? In actual fact, there's no difference. In both cases, we can run arbitrary codes. It's just in one case, we're doing it remotely, sitting in a comfortable chair far away. And on the other hand, we're just doing it right on the console of the ATM. We have already shown it. And periodically, vendors and people working with the ATMs are saying, well, we haven't seen this ATM. You've assembled it yourself almost in a garage and done something that I don't really understand. But Olga will now tell you how it really happens in the large world. Yes, this is a screenshot from the video that we showed at Black Hat 2014. And now let's try and show how can actually execute arbitrary code on the ATM. If it's a known ATM that you saw yesterday, that you see today, you're going to see tomorrow. You're going to use it. Here we have a situation vacuum where the bad guy has found a key somewhere and now opens the service zone that, as I said, is protected only with a plastic door. They take the hacker flash drive containing this code, take the keyboard that the vendor has put into the ATM with the foresight. You're laughing, but there are some vendors who do include keyboards in the kit of the ATM. To simplify the demonstration, we've already got access to the operating system. But in principle, if some of you have attended Sergei Golovanov's presentation, they see an example of real-life malware to execute arbitrary code. So the malefactor got the first portion of foreign money. So they run the code once again. Gets another portion of foreign cash, and this may go to infinity. So where such a great ATMs can be found with this amazing idea? If you go to Shadam and if you ask Shadam the right questions, it will see both the IP addresses and the operating system and the vulnerabilities that can be found, all the ports that can be open, and in certain cases, please take note of some letters here. He may even understand where physically this ATM is. And I don't know if you can see it very well or not, but our yesterday's scanning result is like this. So actually, you can come here, look around, and understand which ATM was either rebuilt or brought here. So I can explain that. In terms of unsecure networks, anyone can get direct to the ATM equipment, sending commands to applications that will translate it to into the hardware language. Bad guys can use processor emulators. It's kind of a gift from the vendor. These are the utilities developed specifically for the bank's engineers to understand how correctly the ATMs work with the processing is organized. But as you can understand, malefactors can use all this in their own purposes. So it's no rocket science. Also, they can create their own magic box from which the same commands will emerge. They will be very much like the commands issued by a real processing center. And again, I'm not sure how well you can see, but this is the admin log in the host-based bank. And it's just too simple. So what's highlighted in green are the third pairs of zeros and the last number of 40, which means that the ATM has to hand out 40 sheets of paper in cassette 4. Well, meaning that it's about 200,000 for a time. And you need don't more than 10 to 15 minutes to to penetrate the ATM. So even if the bank has seen something and tried to respond to that, there won't be even time for people to arrive. And this is another example how we can exploit, or better to say benefit, from an ATM where we, as the manufacturer, found some root VPN client and something like that. Well, it's clear that it's the picture is taken as our test lab. No bank will want their logos to be shown at this type of events. But this is a true ATM. The malefactor sees that there's a router, so they come up there and do their dirty things, taking the patch cords of ATM from the root and start waiting until the ATM goes offline. Well, it's all happened, and now it can connect it to its magic box. I'm sure you're guessing which company it is. And here, some small processing center is implemented. We are waiting until the manufacturer is waiting until the ATM turns offline. So it now happens. And now it only works from this small processing system next to it, whereas the ATM doesn't know anything about it. They don't need to change any settings. Another malefactor has arrived with some card. It may be just a regular loyalty card from the grocery store. And they can do all the different things that are supposed to be done by an end user when they want to suppress some money from the ATM. Well, the actions are simple and usual, but not altogether, because periodically we're getting screens here we don't exist in the normal mode. For instance, we can select from which to cassette to pick the money. So we're waiting until the transaction is finished processing, while the ATM squeaks and scratches with its insides and hands out a few bills. The check, in this case, can contain any information. We can add smileys or Happy New Year wishes and whatever else. So this is the way how we can withdraw any amount of money from any card by just identifying some router, some networking equipment, or free access to the bank's patch code, or again by having gotten access to the network, either using some drawbacks, some vulnerabilities.
Действо происходило здесь же на PHDays, по-моему, в 2013 году, когда один наш знакомый, который банкомат с этого ракурса увидел впервые, с помощью нехитрого набора и Я за вас рада. Вот в главе получен доступ.
Here we are. He's got access to the service zone, and it's good time for him to do the dirty job. In many instances, we do not even need to make it into the ATM. If we look around, we will see unlocked ATMs while they're on. While they're on. You can also see a lot of network equipment and patch cords. Sometimes engineers are so lazy that they stick the USB cable out of the ATM. All these pictures have nothing to do with Photoshop. They're real-life ATMs. You can see such an ATM walking along a street. You see it, you say, let's take a picture of it. Sometimes we invite friends to enjoy them. Well, the first part was about networks. Now let's see what can be done when there is access to a USB port. Sometimes we hear from security people from banks very interesting stories. On Monday, early in the morning, while clerks are on the way to the office, cash and transit guys come to maintain ATMs. They see them locked. They expect them to contain several million rubles, but the money is not there. They look into log files, records, and see nothing there. But there is a video showing that a couple of weeks ago, someone looking like a maintenance engineer approached the ATM, opened the service zone with his key, placed some box there looking like a router, then locked the ATM and left. After that, some people came looking like customers, clients, doing something. Then another guy looking like a technician comes about, and now pedestrians react to him because he looks like an engineer. He unlocks the ATM, takes the safe box, and goes away. For security guys and cash and transit guys, it looks like magic, but there is no magic at all. At least in this particular case. What happened is a trivial story. The bad guy connected directly to the device. How many of you heard about black box attacks? Hi, I'm happy to see you here. Keep on listening. The system module that's designed to control the device, this small device was connected. It can be any kind of controller. It is connected directly to the dispenser instead of the system module. That's why there are no log files at all, because all the log files are based on the system module, which is not part of this configuration anymore. As I said, the device was connected via COM ports or USB ports. We can send commands directly to any device bypassing this intermediate software with its drivers and so forth. With a card reader, we can use it as a skimmer. We actually transform our ATM into a skimmer. In the internet, we can find software-based sniffers, install them on certain ports, and collect track plain text information. Scenario 2, we can come up with a dancer or PRP and install a hardware-based sniffer, in which case we'll have a MAX-type tracker We can also collect data from EMV chips. In the tracker, such a tracker is enough to duplicate cards. In those countries where there is still no EMV, like the US and some others, moreover, if we obtain PIN codes, we will be able to collect cash. These data are also sufficient to engage in cash non-present, with card non-present transactions. And now I'll try to show you what can be achieved with dispenser. It is a lab again, but it is a real-life ATM. The bad guy bought the key online. The ATM is in the in-service mode. The bad guy takes his box with a battery and a dongle. He disconnects the dispenser's USB cable from the system module and connects it to his device, to his box, small box. The ATM is still in the service mode. It does not work. It does not see the dispenser. However, the dispenser continues working. The bad guy gets connected to the dongle, sends command from a telephone handset or any other device, and waits. And here he gets some amount in foreign currency. Our bad guy is pretty modest, only taking a couple of notes. Real life bad guys will be keeping on doing this as long as there is space in their rucksacks. I mentioned last year all the disadvantages of working with COM ports. The manufacturers say we don't use any COM ports, we use USBs, but in the previous example, you saw an example of attacking an ATM through USB. Unfortunately, it is very dangerous to be alone in such situations. If there are bankers here, you should know that bankers in many countries experience these problems. The question is, how can this be countered? How can we protect ourselves against this? We are trying something, but we never manage to achieve the result that we want. The classical answer may be, why don't you engage all those security options? They are there for your protection. Unfortunately, people don't do it because every next option can break something. When an ATM is out of service, it does not yield any revenue. However, it cannot be broken. Bro, banks say, we're a small bank. We have a network of 100 ATMs, but you're not alone. Get united with other people. Speak openly about it. Say, there are problems out there. You're not expected to disclose this information to the general public. There is still interbank interaction. There are various consortia. Unfortunately, PCI DSS is not a silver bullet, and the audits that are carried out in order to get licenses and process transactions, they don't help to get rid of all the problems. Security is a process rather than result. To maintain those processes, it is necessary to understand things and analyze things. And of course, proactive analysis is much better than incident investigation. Once you are robbed, you have lost money. knowing the problems that you face, you're in a great position to get rid of them, and you can be helped by various people and companies. And don't forget, bad guys are always watching you. They are always near. If you're not ready to spend money on security, be prepared to switch off all your ATMs, remove them, and run about to collect your money. Stay safe. And if you have any questions, don't hesitate to ask them. Hi, my question is about antiviral software. Antivirus vendors create ad hoc software product for banks. But as far as I know, Kaspersky Lab does not have such software. Some of them come up with abbreviated classical antiviral products. Others come up with application controllers, saying that that is what ATMs need. What do you think? What's more correct for ATM networks? We believe that it is better to have all the available security methods in place. An ATM is a pretty fragile tool, and by adding antiviral software to it and integrity control software, will overload it. It can be tackled. I think that the companies offering different solutions also offer solutions to various operation and maintenance challenges. You don't keep your eyes shut on the fact that those applications in white lists can also have vulnerabilities, and integrity control systems can also be bypassed. They can also have vulnerabilities such as voluntary code execution to bypass barriers. There is no silver bullet. And we should get closer, try to get closer to the ideal situation by making small steps. Good afternoon. My question is about hardware gateways. How come that they can be installed near ATMs, granting access to bypassers? Why don't people build them in? Good question. Unfortunately, those who maintain ATMs are lazy people, and we should remember about it. And it's not accidental. Laying your cable in an ATM in such a way as to make other devices fit into it is quite labor-intensive process. With thousands of ATMs, it will take quite a lot of time. You can do this on some part of your ATMs, but some of them will stay vulnerable. The problems that we demonstrated to you, the examples that you could see on our slides, they are exceptions to the rule. However, each of those examples account for up to 15 million ruble of losses for banks. There is another challenge. An ATM is just a box made from iron, but its front panel is plastic. And quite often, gas heaters are used to make this plastic melt down to cut into those boxes. We hope someday bankers inform us why they don't hide routers. Sometimes they don't fit into ATMs. ATMs are not designed to accommodate routers or coffee machines. However, Some banks install metal enclosures with locks where they put their equipment, peripheral equipment, sometimes cameras, but many banks just collocate them. And it's still a big question mark why they don't come up with such metal enclosures. Have the banks learned how to counter people making several notes, cutting several notes of just one? There can be yes, of course they learn how to do that. And it's as simple as that. One should improve protection methods. Previously, people would use voice scanners to read machine-readable properties. Today, the situation is changing gradually. Every time there is fraudulent fake note, or when there are cut notes, or the vendors engage in improving their firmware to make sure that counterfeit notes would not be accepted by validators. It is about updating your firmware, but sometimes hardware upgrades are required. No microphone, sorry for this. The answer is you're right. Good afternoon. A question from bankers. Which detection methods or prevention methods do you consider being better protection against black box attacks? And which tools are the best for each of the methods? Of course, I could dwell upon each of those methods. Well, I think that the best solution and the most complex one is to impose some pressure upon vendors to make them improve their devices in terms of USB protection. There can also be additional hardware that can be provided by those who maintain ATMs to detect I've forgotten what I wanted to say. You've been talking about prevention. How about detection? There may be detection of thermal devices. Dispensers can be disconnected from house. Communication channels can be redundant. Very often, banks only use Ethernet. And if the Ethernet interface is disconnected, the ATM is unable to convey any information. An ATM is a large piece of hardware. If you hit it with a hammer, all your sensors will go down. Very often, banks don't even send engineers on site in such cases. Which method is better in your opinion? Correct me if I'm wrong, but you seem to have broken many dozens of ATMs. Well, I think that the most efficient way is to put it in a concrete enclosure and something more feasible. I think it should be a comprehensive approach. There are a lot of vendors offering pseudo-protected data protection methods for COM ports or USB ports, but we know from experience that they don't work. You should impose pressure upon vendors to make them offer protected dispensers, for dispensers not to accept any other commands but only the commands from the main application, and for those commands to be only accepted if they come from the processing center. Some vendors already offer solutions to prevent network attacks, substitution processing, MAC authentication based on some protocols, SSL, although PCI DSS do not like SSL. There are a number of measures that have already been implemented, but are still not used by banks. When we come to analyze ATM protection, sometimes we see pretty scary situation. People buying ATMs, installing them, pushing OK with no additional settings. If you look into Shudder, you will see there thousands of ATMs across the globe, although they shouldn't be there. So they should be an end-to-end approach is required, comprehensive approach. It's not enough to check out all the boxes. It should be a set of measures employed on a regular basis, and you should audit your entire ATM networks for integrity. In our work, we identify a lot of vulnerabilities exposing ATMs to attacks. Unfortunately, banks only react when something happened. They are reluctant to introduce proactive approaches. When we analyze accidents, we understand that a bank could have spent money on a full-fledged PIN test, but they don't do that. And the bank may have some 500 ATMs in one city. If there is a vulnerability on one of them, it is very much likely that the same vulnerability will be found on the others. Are there any good figures, good statistics? That some ATMs, for example, may require higher skills from bad guys to be broken. What kind of stats do you want? Figures or letters? Are there any banks or ATM networks that are really well protected against with less problems with unprotected routers and so forth? If you're asking as a bank client or ATM users, it's up to you. You have to look around and try to understand if everything is okay with this ATM. If all of the wires are on their places, respective places, I recommend that you use ATMs that are inside bank branches. Of course, they can be exposed to attacks too, but I don't recommend that you withdraw cash from ATMs that are in unlit blind alleys, for example. Good afternoon. My question is plain and simple. Is risk insurance practiced in Russia for such risks? Good question. It's exactly what's used by banks. Is there a last resort that help banks protect themselves? They understand that should there be robbery and some amount is stolen, their insurance company would provide coverage, but they don't take just one thing into account. If it is repeated over and over again, insurance fees grow, and confidence in such bank boils down. It's like with automobiles. And at a certain point in time, the insurance company will say no. And the bank will be left with no choice. If the bank goes to another insurance company, there will be high probability that that other company will also say no. The last resort would be going to somebody ready to protect the ATMs. No microphone, sorry for this. Any more questions? Thank you very much for your presentation. Thank you.
Просьба, да, выбрать 2 человек, которые получат презенты.
Так, мы тут посовещались кратенько и пришли к единогласному мнению, что нам понравился вопрос мужчины из банка про всякие разные вопросы и вопрос про страхование. Люди, подойдите, пожалуйста, к нам, задававшие эти вопросы. Всем спасибо, что потратили на нас время.